Does radiometric dating provide us an accurate date for the age of the Earth? That's what we're going to be talking about tonight with Dr. Mike Houts, who has a PhD in nuclear engineering from MIT, was working at Los Alamos Labs for many years. Mike, do you want to tell us a little bit more about yourself?
Appreciate you having me on the show, and it's really a fascinating topic. Being able to, just discuss really everything related to origins, or really ultimately where we choose to put our faith. And so are we putting our faith in the Bible, or are we putting our faith elsewhere? And so I just really appreciate the opportunity to be on the show. I have been. God's blessed me with a really fun career. I was always interested in science and engineering, and went to school, got a nuclear engineering degree, went out to Los Alamos National Lab for 11 years. And then right now I'm at NASA, but I'll be retiring December 31st. And so, again, it's just a really fun topic. So thank you again for having me on the show here.
Well, thank you for coming on. And honestly, I think people, when they think about radiometric dating, they basically have the idea that we know it completely works. It has shown the age of the Earth. There's no question here that this is good evidence for the Earth being 4.5 billion years old, and all the other dates that they say in between. What are your initial thoughts on that before we start your presentation?
Well, that's what'll be fun about the discussion, is because, when we look at radiometric dating, you're really just measuring the ratio of isotopes. And so there's different, of course, everyone's heard a lot about carbon dating, which is really just looking at the ratio of carbon-14 to carbon. But you have uranium lead, you have samarium neodymium, you have potassium argon, you have a lot of different dating methods. But again, we don't actually measure an age. What we do is we measure a variety of things, and it really comes down to, say, ratios of isotopes in a sample. And then with those ratios, then we make assumptions to come to a date. And a lot of times we've had, just throughout science, we figured out, hey, our assumptions are wrong, or they weren't quite true here, or they were. And so we'll talk a lot about that, just some of the assumptions that go into it, and then again, just some of the if certain assumptions are wrong, well, how does that basically make a radiometric dating not just consistent with all the other dating methods. And I should mention, most dating methods are very consistent with the Earth being a few thousand years old. It's really the radiometric dating with certain assumptions that gets us, like you said, the 4.54 billion years. And so just look at some of the ways that if those assumptions are wrong, that would bring the radiometric dates back into not only the in line with the other secular dating methods, but also in line with the Bible. So anyway, we'll be looking forward to the discussion.
Awesome. Well, I can't wait. And I just feel like I found a bar of gold when I met you. Because
I just love talking about it.
Well, but there's a lot of skeptics out there. And when I or other people have challenged radiometric dating in the past, they say, well, why don't you bring someone on who actually, knows about this? And now I have a nuclear engineer. Guys, is it enough skeptics to have somebody who has a PhD in nuclear engineering come on and talk about radiometric dating? So I'm looking forward to this presentation.
Okay. All right, great. Well, I guess we can go ahead and jump in. That sounds good. Okay, so again, that presentation is just Age of the Earth. We'll say a lot of good additional information available at apologeticspress.org. And, feel free to send me an email. I actually like having, cordial discussions about this. I actually enjoy talking with absolutely everybody. And I don't feel like if people disagree, they have to be enemies. It seems like that's sometimes becoming a requirement in some, today. But I really don't like that, because some of the most brilliant scientists I know have been people that are just happy talking about areas that they agree on, areas they disagree on. So going on from there, I'll be right up front with my biases. I'm a Christian. I became a Christian when I was 36, when I obeyed the gospel, and started out being an atheist. I didn't hate Christians, and that goes back to my idea that, hey, you might disagree with someone, but you don't have to hate them. But I just started looking at the evidence, a lot of, just things like the fact that we have free will, the fact that we can make a choice. Well, it proves we're not just a chemical reaction. It proves we have to have a soul. And that's won't spend a lot of time on that, but, the atheists and Christians agree on that completely. And then And then also, even just looking at, like, say, life making itself. If you get a chance, and again, no matter which side you come down, just go ask a university. Just say, hey, if do you think if you had a few months, just starting with basic chemicals, you could make life from non-living material? And they'll say no, or they'll just kick you out. I mean, again, that goes back to, are they willing to listen to people they disagree with? Because we've never come close to making life from basic chemicals. Yet we teach it as fact that somehow life made itself 3.8 billion years ago. So it'd be, that's worse than saying an iPhone just made itself. And so anyway, a lot of things we could talk about, but those are some of the things that started leading me towards becoming a Christian. And then, of course, once you start going down that path, you start looking at just all the different areas of discussion, and you start finding out that, well, true science is very consistent with the Bible, and in a lot of respects, true science is catching up with the Bible. So anyway, that's where I'll be coming from. But again, welcome discussion. First of all, we do need to rely on the Bible. 2 Timothy 3:16. All scripture is given by inspiration of God and is profitable for doctrine, for reproof, for correction, for instruction in righteousness, that the man of God may be complete, thoroughly equipped for every good work. And then John 17:17, sanctify them by your truth. Your word is truth. Now, when we talk about the age of the earth, a lot of times, again, it's one of the last strongholds for people that are opposed to the Bible. You don't, Christians, we don't get attacked by people saying, oh, you silly Christians, you think you can make choices, or you think you can think. Because essentially, if we were just a chemical reaction, chemical reactions don't make choices. A piece of wood burning in a fire doesn't choose where it's going to burn. A rocket engine doesn't choose how it's going to burn. It's very deterministic. If we were just a chemical reaction, could not make even a simple choice. But you usually don't get attacked on that because, pretty much everybody knows, no, I can make choices for better or worse. I can make choices. I can think. I mean, I can actually, think about subjects and, talk about subjects. And so again, which I couldn't do if God had not given me a soul. So you don't get attacked on that. And again, don't get attacked on, everybody knows life can just make itself, because in reality, from true science, we know no, life is so incredibly complicated. Saying life could just make itself, it's again worse than saying a phone or computer or airplane or space shuttle could just make itself. So the age of the earth, if someone's really wanting to attack the Bible, that's kind of what I say, the last strongholds. And so I use the word stronghold. 2 Corinthians 10:3-5 says, for though we walk in the flesh, we do not war according to the flesh. For the weapons of our warfare are not carnal, but mighty in God for pulling down strongholds, casting down arguments and every high thing that exalts itself against the knowledge of God, bringing every thought into captivity to the obedience of Christ. We need to expect to be persecuted. Persecuted, I shouldn't say that because it's too strong of a term. We look at how Christians were persecuted in the first century. I mean, they were being burned at stakes and literally crucified. And so it's so what we undergo today might be some harsh discussions, but it really doesn't. To me, probably should use a different word. But 1 Peter 3:13-15 does tell us, says, and who is he who will harm you if you become followers of what is good? But even if you should suffer for righteousness' sake, you are blessed. Do not be afraid of their threats, nor be troubled, but sanctify the Lord God in your hearts, and always be ready to give a defense to everyone who asks you a reason for the hope that is in you with meekness and fear. Also, the Bible tells us to love our neighbors as ourselves. Well, the best way to love our neighbors is encourage them to obey the gospel. Mark 12:29-31. Jesus answered, the foremost is, hear, O Israel, the Lord our God is one Lord. And you shall love the Lord your God with all your heart, with all your soul, with all your mind, and with all your strength. The second is this, you shall love your neighbors yourself. There's no other commandment greater than these. And what I mean by that is, when you think about it, really long life on earth is still, 100 years. One of the, as a Stanford professor, we'll be quoting some later in the presentation, brilliant researcher. He actually lived to be 100 years old, and people were still very sad when he passed away. But a lot of people look at it and say, wow, he lived to be 100 years old. That's a really long physical life. And it is a long physical life. But again, that's zero compared to eternity. We think about eternity is completely outside the dimension of time. But if we view it, say, as an infinite number of years, well, longest life on earth, 100 years, 969 years, that's all zero compared to eternity. And so, again, if we're loving our neighbors as ourselves, we have to, encourage them to obey the gospel so that basically they'll be spending eternity with God rather than eternity separated from God. But again, that is their choice, and so that's why this is, again, an important topic to really help people realize they can put their full faith in the Bible. So start talking about the age of the Earth. One thing that's important to point out is most methods of dating indicate that the Earth is a few thousand years old. It's consistent with that. And so what I mean by that is if you use, I could say uniformitarian assumptions, but some of these you actually do take into account effects of the flood. But you'll notice those assumptions when you're taking into account a recent creation, when you're taking into account the effects of the flood. Again, that's starting from the standpoint that the Bible's true. And so when we talk about the assumptions, if you start from that, then that's by definition going to give you a different interpretation, same evidence, but different interpretation than if someone was to start out saying that, well, the Bible has to be false, that, there can't be a God, everything has to be random, everything has to be, based on atheism. And so when we go through these, for example, we say very little sediment on the seafloor. Even looking at measured rates of sedimentation today, like how fast does say mud flowing from the Mississippi River into the Gulf of Mexico, and just look at rivers around the world. Well, that puts a peak age on the Earth that's far less than what people would say that the age of the Earth or the age of the oceans are. And so, in other words, the continents would have eroded away just based on the rate that sediment is flowing into the ocean basins versus the rate that is being removed. And then when we take into account the effects of the flood, where you would have had just a huge amount of sediment being washed off the continents at the end of the flood, then they can become very consistent with the Earth being on the order of 6,000 years old. And so that's again, just I'll keep using the word consistent because we're talking about what some people call historical science, and so we're making those assumptions going backwards. But with those two assumptions, it becomes, again, very consistent with that age. Bent rock layers. You have rock layers that essentially it's the same layer. It's the same color and grain size, and it's basically again this obviously the same layer, but they're bent. So in other words, they'll have sometimes you'll have almost S curves, and they'll be 100 feet tall or more. Well, those S curves, there's no cracks in them. And so you can go to like the bottom of the Grand Canyon and look at some of these bent rock layers, and you can just take that rock, it just crumbles between your fingers. It's very brittle, but you look at those bends and there's no cracks in the bends. So again, it's very consistent with that layers being laid down rapidly and then being bent before they had time to harden. And many of those layers, they'll say, across that whole distance, maybe hundreds of millions of years supposedly passed where that rock would have hardened, but you don't see any cracks in those bends. And so again, very consistent with the idea that no, they were those layers were again deposited very rapidly. In that case, it would be again during the flood, and then bent before they hardened. And of course, we see the rapid sedimentation, the rapid carving in canyons, just in events like Mount St. Helens. And so it's not, that's become very accepted as we start looking at these very small catastrophes, seeing what can occur because of them. Soft tissue and fossils. Now, this one's interesting. When it was first reported, I think it's first publicized, I want to say it's about 2005. There was so much pushback, against that soft tissue and fossils. There'd be people saying that, well, no matter what the evidence was, they'd never believe we'd find soft tissue in dinosaur fossils. And to her credit, the researcher, she was very persistent. She kept doing, digging deeper, letting people see all her data. That was important, redoing experiments. And so a lot of pushback there. And so now it's accepted that there is soft tissue in dinosaur bones, even though it was said to be impossible. And it would be impossible if those were really millions of years old. And it's just said, well, we don't know how they could, last millions of years, but we know it must have. And so it's kind of interesting, just kind of brush it away. But it's just interesting. The initial reaction was, well, that can't possibly be true. We'll see some of that, talk about some of that later tonight too, just where something's introduced and you get this huge pushback, well, that couldn't possibly be true. But then we, of course, find out that it actually is true, down the road. Sometimes we find out it's false too. I should be fair. There's a lot of things in physics where people are thinking they see something and it ends up they weren't really seeing something. So it can go both ways. But this is just an example where you went from that's impossible to something that's now generally accepted. Rapidly decaying magnetic field. you just look at the total energy in the Earth's magnetic field that appears to be decaying on an exponential. And we're pretty confident that that's been occurring over the last, at least 1,000 years. And so if you extrapolate that back along that exponential, also very consistent with the Earth being young, it's also a very straightforward explanation for the Earth's magnetic field and its behavior that we're seeing, and the magnetic fields that we see around other moons and planets in the solar system. So again, very consistent with the relatively young Earth. Or you say relatively young is still, no one can really imagine how long 6,000 years is. So a lot of people say, oh, that's a young Earth, but it's actually still really old. A lot obviously happens in that amount of time. Helium and radioactive rocks. The idea there, and we will actually talk about this in the radiometric dating, is certain isotopes, in this case it'd be uranium-238 or uranium-235, when they decay to lead isotopes, they actually release helium. And so now we can look at those rocks and say, okay, we know how much helium, we know how much, if we assume, say we start with pure uranium, we know how much uranium, what fraction of that uranium has decayed into lead. And then based on that, we know how much helium would have been produced. And we can then also measure how much helium remains in this case, it would be, say, a zircon crystal. And so you actually have two ways of estimating the age of that particular crystal. So, and so it's kind of interesting. You can get two independent ways of dating something. And that's one of the areas where it's, again, very consistent with a lot of radioactive decay having occurred, but that radioactive decay actually having occurred quickly. And so that's something we'll talk about again in a later slide. We do find carbon-14 in fossils, coal, and diamonds. What's interesting is, carbon-14 has a 5,730 year half-life. And so that means half of it's going away every 5,730 years. If a sample was, even 100,000 years old, let alone 1,000,000 years old or older, as some of them are claimed, fossil or coal or diamonds, you wouldn't see any carbon-14, but it's routinely found. And that's, using very good laboratory equipment. So it's not experimental error, using very good techniques so you don't get contamination. And so, again, that's I'd say that one's just consistent with, okay, we're making a wrong assumption somewhere because, that carbon-14 should not be in that sample. Very little salt in the sea. That's, again, analogous to the sediment on the seafloor. And then also DNA in ancient bacteria. That's just a case where, we see this DNA in bacteria. Sometimes they'll claim it's over 100 million years old, but the DNA is basically the same as DNA in bacteria today, which would be kind of interesting, because that would mean, well, did it really not change, over that supposed long period of time? But then also just the fact that the DNA still exists is intact enough. It's very, very hard to explain how DNA could possibly last that long. And so anyway, so all methods, and there's dozens more, consistent with the Earth being a few thousand years old. But radiometric dating using standard assumptions, it's really kind of, I'll say, the last major discrepancy. And so that's what we'll be talking about more tonight. So 2 Peter 3:3-6, and this is really going to address the uniformitarian assumption, which just means, everything's always been the same. Well, again, biblically, we know that's not true. 2 Peter 3:3-6 says, knowing this first, that scoffers will come in the last days, walking according to their own lusts, and saying, where is the promise of his coming? For since the fathers fell asleep, all things continue as they were from the beginning of creation. For this they willfully forget, that by the word of God the heavens were of old, and the earth standing out of water and in the water, by which the world that then existed perished, being flooded with water. So again, it's talking about, people will say, scoffers, since really since the beginning of creation, everything's been the same. And it's like, well, that's not true. If nothing else, we certainly had the flood, but also that creation could have been very very recent, relatively recent. Again, thousands of years ago, but still relatively recent. Okay, so radiometric dating. Just getting into that a little bit. I'll go ahead and read this, but it's I'll try to interject some too. So when talking about radiometric dating, it's basically use different isotopes. And they're used in radiometric dating. It depends on the type of sample. So you really have to have the isotopes present in the sample, obviously, to use that dating technique. As the name implies, carbon dating requires at a minimum the sample contain an adequate amount of carbon. And then radiometric dating methods also based on decay of potassium-40 to argon-40. That's one that you see a lot in dating lava flows. You have a volcano erupt, or we see a volcano that had erupted. We're trying to to determine how old that was, how long ago that happened. You have a decay of uranium-238 to lead-206. That's what we're seeing in zircon crystals. Again, that's the one that produces helium. Decay of rubidium-87 to strontium-87, decay of samarium-147 to neodymium-143. Other decay chains can also be used. But again, the key is all we're really measuring when we do these dating methods is just this ratio of isotopes. And so then to convert that ratio of isotopes into an estimated age, that's where we need to make assumptions. And so the assumptions that we make, radiometric dating depends on at least three assumptions. First is the degree to which radioactive decay rates have fluctuated throughout the life of the sample being dated. Second would be the original concentrations of the isotopes being used to date the sample. And the third would be the addition or subtraction of isotopes being used to date the sample throughout the life of the sample. And so, just talking about a couple of those assumptions, we'll talk about carbon dating first. But basically, changes in the carbon-14 to carbon ratio have a significant effect on carbon dating. When you think about it, because that's all we measure now is again this carbon-14 to carbon ratio when we find a sample. And typically the assumption is, well, when that sample was created, say the tree was cut down that was used to make a wooden bowl, or whatever the process was, the assumption is that carbon-14 to carbon ratio is about the same as today. But if it was different in the past, that would have a huge effect on the carbon dates that were obtained. And then the other one is going back to the first one. If there were changes in decay rates during creation week and the flood, that would also have had a significant effect on all radiometric age estimates. Because again, it's all we're doing is measuring ratios of isotopes, and then we're applying these particular assumptions. So so starting out with radiocarbon dating. So basically it uses carbon-14. And so when you think about an isotope, carbon always has 6 protons, but carbon-14, it's 6 protons and 8 neutrons. So again, the 14, that's the sum of the protons and neutrons. And it's primarily formed by cosmic ray interactions with the atmosphere. And then you have neutrons that are released by interactions that react with nitrogen-14, and then it has actually a nuclear reaction where the neutrons absorbed or protons released turns it into carbon-14. And so that's depicted at the diagram to the right. And so carbon-14 is it ends up, because you're making this carbon-14, it's a very small fraction of carbon in the atmosphere. It's about 1 part per trillion. So only about 1 part per trillion of the carbon in the atmosphere is actually this carbon-14, and the rest it's actually like 1 in 1.2 trillion. But that's but anyway, that's the ratio that we see today. So that's how it's formed. And so then what you can imagine is the way it works is you have plants and trees obtain carbon from carbon dioxide in the air. So animals eat plants and trees, and then but when the carbon uptake stops, in other words, when basically say the animal dies or the tree dies or then that carbon-14 to carbon ratio, it starts to decrease because it's got that 5,730 year half-life. And so it's so you think of it, it would decrease to 50% of the original concentration in 5,730 years. So that'd be 1 in 2.4 trillion atoms would now be carbon-14 instead of only 1 in 1.2 trillion. 25% of the original concentration after 11,460 years. So 2 half-lives, you're down by a factor of 4. 12.5% of the original concentration after 17,190 years, and so on. And so that's the basic premise behind carbon dating, and a Nobel Prize was awarded, to the person that discovered that. So it's kind of clever. But again, we have to remember the actual measurement is the current ratio of carbon-14 to carbon, and so and that's what those again the age estimates are again completely dependent on that assumption. But then other assumptions are also required too, the ones that we talked about. So what we do is we'll just run through an example and say you had the equation that's used is just a standard radioactive decay equation, but you'd have say you find a sample and you have the carbon-14 concentration in that sample. Well, that would be the carbon-14 concentration of the sample at the time of death. In other words, like when the tree was cut down, or whenever that it stopped absorbing carbon dioxide from the atmosphere, and that's times e to the negative lambda t. And so in this case, lambda is 0.6931 divided by the carbon-14 half-life, just the terms in the equation. T is time, E is the base of natural logarithm, C is concentration, C0 is concentration of death. And so the way that equation could be written and defining those terms is just the current concentration. We measure now, it's the concentration at the time of death times e to the negative lambda t. And so, and of course, in this equation, you're also assuming that the half-life remained constant the whole time. And so going on from there, if the carbon-14 concentration of sample, just to give an example, say we find something that's 2% of the atmospheric carbon-14 concentration today. So using what I guess would you say uniformitarian atheistic assumptions, you say how old is the sample? Well, in this case, you just run it through that equation. C equals C0 e to the negative lambda t. Assume a constant decay rate. Which it's fine. So that lets us calculate lambda. And then assume that the C0 is roughly equal to the C14 concentration today. Now that's the assumption. And so if we run with those assumptions, you just plug it in. The concentration we're seeing today is 0.02 that, a 50th of what we're at to the carbon concentration we measure in the sample today is only 2% of what the current atmospheric concentration is, and just solve the equation, we get a date for whatever you're dating of 32,330 years. And so that's, of course, not a biblical age. You can't fit 32,330 years in the Bible. But if those were the assumptions, that's what you'd get. And those types of dates would make people think, well, there's got to be, maybe go back and insert extra years somehow into the Bible, things like that. But the other way you can look at it is, well, what if you use assumptions that are biblically consistent? And so the biblically consistent assumptions, this could be, let's think about what could be the effects of the flood. And so we'll talk about that more. But during the flood, we would assume there was a tremendous amount of carbon buried. And everyone agrees there was a lot of carbon buried a long time ago. It's just the long time ago is what people are disagreeing on. What the specifics is on the long time ago. And so what you'd have would be, in that case, say if you had a significant catastrophe, we'll just call it, and you had that same exact data. So again, the sample, it's 2% of the C14 to C ratio than what we see in the atmosphere today. You say, well, how old is the sample? It's actually impossible to tell, because you've got a variable. You can say, what was the actual concentration at the time that sample died? But say it was 1/30 of today's atmospheric carbon-14 concentration. And we know estimates go all the way up to like 200 times as much carbon buried underground than there is in the biosphere right now. So you can have a huge range of, depending on how the carbon-14 was distributed in the original creation, how it was distributed at the time of the flood, you could have a huge variation in that, and what that concentration was around the time of the flood. Well, you take the same, basically the same exact data, so now you say 0.02, but you assume that the initial concentration was, say, a 30th of what it is today. Same equations. Well, now you get a time for that sample being formed of 4,210 years ago. So now that is, very biblically consistent. Okay, and so
and it sounds like that might be the source of a lot of these archaeological, because the carbon dating, of course, is not part of the millions of years, but there's a lot of archaeological sites where they'll date something, some piece of fabric or something like that, and say it was such and such old. So do you think that's the problem with a lot of that dating?
Yeah. And we notice that once you get 1,000 years after the flood, they start to become consistent again. But if you look, like some of the really early civilizations that popped up right after the Tower of Babel, that's where you start getting these inconsistencies, and you start getting older. So you're getting really close to the flood at that point, and so that's where you're getting the inconsistencies. And the reason is just the carbon-14 to carbon ratio would have settled out after the flood, and there is agreement on this. If you go into even the Smithsonian Museum of Natural History, they'll even point out that the CO2 concentration in the atmosphere was like 15 times higher, and you get in the distant past. They won't, how distant, there'll be a disagreement on, but they'll, there's acknowledging that the, much higher CO2 concentrations in the atmosphere, and I guess what they would just say the distance past, they'll acknowledge that, most of the carbon and coal, oil, natural gas used to be in the biosphere. If not all of it, and so it's and so again, these are if someone thinks about it, these are consistent assumptions. It's just the exact time frame that differences. And I should mention on things like the archaeological sites, a lot of times you'll have someone will say, well, we're not using carbon dating. We're just looking to see, well, like how deep is that pottery buried, or what layer is it in, or how much basically residue is on the pottery. What's the pottery style? And they're just using that to date, say whatever tell or whatever they're digging in. But it turns out everything basically ties back to carbon dating. And so at some point, carbon dating was used to establish, how long ago was that pottery in style? How long ago, until you get to this certain layer. And if that carbon dating was wrong, then everything based on that carbon dating is also wrong. And so just giving an example, say I have a pin here, and say I took this pin to a lab, and I asked, okay, how long is this pin? And they came back and they said, well, it's 100 meters long. Okay, so now I know this pin is 100 meters long. And so I say I measure my laptop. Okay, how big is my laptop? Well, I got 100 meters, 200 meters, about 220 meters long. Okay, so my laptop is now 220 meters long. Now I want to measure my desk. And so I won't move my laptop, but I'd say, my desk is maybe 4 laptops across. Okay, so now my laptop, we're coming up on 900 meters long for my desk. And then I want to measure my room. I could move the desk across my room, and I'm coming out probably, I don't know, maybe right at like 3 kilometers for the size of my room. And so if someone says, well, how big is your office? And I'll say, well, it's 3 kilometers across. And they said, oh, did you use your pen to measure it? Because, we know those pins are usually measured inaccurately. And I'd say, no, I didn't use my pen. I used my desk. Okay, so that's what you run into. If everything's calibrated back to carbon dating, and that carbon dating is wrong, then all of the methods are going to be wrong along those lines. And so, but again, that's the flood. I think the go through just some of the other implications. Did that kind of make sense or answer the question a little? Or
oh, that was a great example. I love that. Yeah,
okay,
that was good.
Okay.
Thanks.
So then you go. Just other discussion points. We mentioned briefly earlier, how can there be carbon-14 in coal and diamonds, supposedly millions of years old? Again, with a half-life of 5,730 years, all that carbon-14 should be gone. How much carbon-14 was originally on the Earth? How is it distributed? 5,730 years, if you're, if someone thinks, well, the Earth's 4.54 billion years old, it doesn't matter, because the original carbon-14 would be long gone. But if someone's trusting the Bible and says, no, it's 6,000 years old, well, that can actually have a really big effect. And so that's, again, just another discussion point. And then, of course, what if radioactive decay rates were accelerated in the past? In other words, if during, say, Creation Week and the flood, those were both miraculous events. But if, say God was using physical processes to trigger those, could that have changed the, basically the radioactive decay rates? And I should mention, all of the, Christians are really fine about saying something was miraculous, but there's a lot of miracles and things like the Big Bang. One of my, I'll call my favorite ones is, the Bible talks about stretching of space like 17 times. And, but it says, God did it. And so they say, well, the stretching of space, that's a miracle. You're not allowed to invoke that. Well, then you say, well, okay, well, then what was inflation? Because in the Big Bang, they have this idea that, basically space stretched, would be another way to phrase it, in a very tiny fraction of a second right after the alleged Big Bang. And so, but because they just say, oh, it just did, they have absolutely no idea what started the inflation. They have absolutely no idea what stopped the inflation, but they just say it just did and try to, so that's basically their miracle. But they won't ever call it a miracle, but it's something they'll never be able to measure, which essentially makes it supernatural. And they're just making an assumption to pretend the Big Bang works. And then what's really ironic is, of course, that's absolutely required to explain the cosmic background radiation, the inflation is, but then they don't basically say that they in other words, it was almost like reverse engineering. They plugged in this fudge factor just to, so it's just interesting. So I'm pretty open about saying, things, miraculous things were happening during Creation Week and the flood, but it's not just Christians. We just might use the word, but all of the so-called secular theories rely on that also. So had that effect, and then what if the cosmic ray flux or spectrum was different in the past? Of course, the cosmic rays hitting the Earth, that depends on the sun's magnetic field, depends on the Earth's magnetic field, and that's of course how the carbon-14 is created. Variation in solar activity, that actually changes the cosmic ray flux hitting the Earth even today, and we can measure that. And it can change by like even a factor of 2 today. If the Earth's magnetic field, the energy is decreasing, we see that. So that's affecting the carbon-14 production rate. Carbon dioxide concentration in air different in the past. So again, most scientists, no matter what their, I guess you'd say their beliefs are, they agree there's a much higher CO2 levels prior to formation of coal, oil, and natural gas deposits. And then also interesting, most of the models of the flood show the oceans warming significantly because of the flood, the fountains of the Great Deep and the rain. Well, as the oceans warm, that releases CO2. So now you're releasing CO2 from the oceans into the air, huge reservoir of CO2 trapped in the ocean. And so that would have a huge effect on the carbon-14 to carbon ratio at the time of the flood. So again, all of the, just making, pretty, reasonable assumptions associated with the effects of the flood. That alone, just that one assumption, brings the carbon dating in line with the biblical account. The carbon dating we see for some of these artifacts and things. And then I think we already talked about this. Just the archaeology used calibrate carbon dating. Actually, the opposites occurred. Things are essentially calibrated based on carbon dating, even tree ring patterns. Not only are they strongly affected by post-flood climate, but when they go to the really older tree ring patterns that they're trying to match, they also rely on carbon dating. And then when you look at the written records of early civilizations, they're typically very consistent with the Bible. Sometimes they're very inconsistent. So when they're inconsistent, which do we believe? And so, again, just admitting the bias, the Christian will say, well, the Bible's proven reliable. We have a lot of evidence that it's reliable, so we'll believe the Bible. But someone else might say, no, no matter what, we don't want to believe the Bible, and so they'll go with the other records. And so it's, but again, that's so again, just the related to archaeology and related to written history, and then just some other discussion points. There are other isotopes produced by cosmic ray interactions with the Earth's atmosphere. You have a beryllium-10, chlorine-36 production rates. Those are very strongly dependent on actually the incident neutron energy. The carbon-14 production cross-section, again, that neutron-proton reaction with nitrogen-14, it's actually highest at very low neutron energies, whereas beryllium-10 production peaks at high energy, chlorine-36 peaks at very high energy, and those isotopes, it's a lot harder to predict how they're going to be transported after formation. So it's so that's why most people, when they're trying to do this, they go back to the carbon-14 dating. Okay, so any discussion on the carbon-14? Going kind of fast, but
oh no, this is perfect. You're not
okay.
going too fast. I don't have any questions right now. That was a really good explanation.
Okay, great. Okay, well, we'll keep going. So now we'll go into again advances in true science. You have shown radiocarbon dating fully consistent with the Bible. Genesis 1:31, then God saw everything that he had made, and indeed it was very good. So the evening and the morning were the sixth day. And then Exodus 20:11, for in 6 days the Lord made the heavens, the earth, the sea, all that is in them, and rested the seventh day. Okay, so now going on to these would be observations on assumptions used to obtain very long ages. And I should mention, a lot of these are still very, I'll say, controversial. This was what I'll be reporting was a lot of the research done by Peter Sturrock, and he, of course, he passed away. He was one that passed away last year. I shouldn't say controversial, but it's not as universally accepted as, say, the soft tissue and dinosaur bones are now. And so you have dozens of very credible scientists saying, yeah, we're seeing these fluctuations, and there's other people still pushing back. So very analogous to the soft tissue and dinosaur bones, but it just should. But it's an interesting discussion. This definitely isn't the only evidence we have for changing decay rates. But it's just kind of interesting. It was about 2006 is when these fluctuating rate of decay rates began to be publicized. And so the observation is, well, the fact that small fluctuations in decay rates, may be occurring while the Earth is relatively stable physically, was consistent with the potential for much larger fluctuations during creation week and the flood. And so you think about it. We have horrible storms and earthquakes, but those are still just really, really minor compared to what would have been happening during creation week and the flood. And so if we do see fluctuations now, what could they have been during creation week and the flood? Significant changes in decay rates would explain, again, the discrepancies between radiometric dating and other methods for estimating the age of the Earth. Because a lot of those methods we went through on the early slides, it'd be really hard to reconcile those with an Earth that's 4.54 billion years old. And there's lots of other ways people estimate the age of the Earth also. And then significant changes in decay rates could also explain discrepancies between radiometric dating and the biblical account. So going on then, I'll just give some of the reports. This was Popular Science back in 2010. And there's probably, went through some of the papers, probably, a couple dozen researchers in this area that are really, think they're onto something as far as these changing rate of decay rates. But there's other researchers that are, saying no. And so it's a good scientific discussion still going on. But this is just some of the articles that came out. It says the sun at 93 million miles away appears to be influencing the decay of radioactive elements inside the Earth, researchers say. A study by Stanford and Purdue scientists found that the core of the sun, where nuclear reactions produce neutrinos, spins more slowly than the surface. This phenomenon might explain changing rates of radioactive decay scientists observed at two separate labs, but does not explain why the decay change happens. That violates the laws of physics as we know them. The article asks, how could the nebulous neutrino, which does not interact with normal matter, be affecting decay rates? No one knows. It might be a previously unknown particle instead. And then some of the quotes from Stanford, these are still out on the Stanford website. And of course, these are talking about Peter Strzok's research. Yeah.
Yeah, and that's what I wanted to ask about him, because Dr. Strzok, he's not a creationist, right?
Oh, no.
He was doing just secular research. He was a secular researcher.
Right. Yeah. As far as I know, none of the researchers are, I mean, as far as I know, they're just all secular researchers. I have to, it's a, I think, how to phrase it. It's as long as a scientist is speaking as a scientist, and they're just reporting on their data and what they've observed, then it shouldn't matter. And so if and so that's in other words, the secular scientists, it's just some really good really
it shouldn't matter.
Scientists.
It shouldn't matter, but people usually assume that creationists can't, they're going to be automatically biased. So
I hate that, because creationists, as I've been doing already, I'll be happy to say hey, this was a miraculous event, from a Christian perspective. So definitely never want to be biased with the data. I just want to, because if nothing else, that would backfire, as far as that could actually cause people to start losing faith. You say, well, this is just the data that we see, and here's how. And again, when you some of the obvious ones are again like life making itself from simple chemicals, and it's just those are the so there's many ways to know we should put our faith in God, and maybe that's another way to phrase it. It's not like if you were ran into someone in the elevator and you had 30 seconds to tell them why they should put their faith in the Bible, probably wouldn't start out with fluctuating radioactive decay rates. I mean, there's a lot of easier ones to do. So that's but it's just so as far as I know, he wasn't. He's just a secular researcher, reporting on what he was seeing. And so I think one of my favorite quotes, I don't have it in here, but it was, so when they did the OSIRIS-REx mission, they found 14 out of 20 amino acids on that near-Earth asteroid, but they were all racemic. In other words, it was a 50-50 mix of left-handed and right-handed amino acids. And one of the researchers, obviously a secular researcher, but they were just really upfront saying they were really disappointed. They'd spent 20 years and they were really hoping to find this huge fraction of left-handed amino acids, because that would have at least added a little bit of, hey, maybe this life from space idea, or building blocks of life from space. But no, it was 50-50. And so they literally said they were disappointed. They were just 20 years they felt like 20 years of their career, but then they went on to say, but that's why we do missions like OSIRIS-REx, to get the data. So I thought that was fantastic. So it was just someone, again, so it was don't know the people, so I always hate judging, definitely not using names, try never to use names, but it's just basically they made it clear that they were really, really, really hoping it might provide some shred of evidence, that you could get these building blocks, from outer space, and they were just so disappointed when it showed the opposite, that now it's because the 14 to 20 you can predict from pretty basic chemistry, and it was just but the even mix of left-handed and right-handed is what really shut down their expectation. So, but sorry.
Yeah, well, I'm glad you're saying this, because a lot of people have just seen the sensational media headlines about
Oh
these
yeah.
various asteroids and are,
Oh yeah. Yeah.
they'll they will say, oh, we found the chemicals, building
Oh,
blocks
building
of
blocks.
life,
Yeah.
and things like that. And so it's important that people know that just finding a racemic mixture of amino acids is means you are nowhere close to life, and it's not even the building blocks of life, because you
Right.
have to have completely left-handed amino acids for life. So I'm glad to hear that, he
Yeah, you have to
spoke
dig
up
a
about
little bit,
that.
but you'll get quotes
Yeah.
like that and a lot. But you have to. You're right. You have to just read some of the more detailed articles. That are really, again, hopefully written by someone that's trying to be objective, not just sensational. But I just go back
Yeah.
to, again, if you go to any, you should be able to go to any high school and just say, hey, I got a free afternoon. Can we just go make some life up in your lab? Just using basic chemicals. I mean, if it happened randomly, you'd be able to do that. I mean, not to. If you just think about everything you could do in a high school lab in a couple hours, how far away you'd get from anything that could reasonably happen randomly. And of course, I mean, we're talking hundreds of billions of dollars in biotechnology, really smart PhDs, incredible labs. No one's come close to making life, just starting with basic chemicals. Though we're getting, God's given us the ability to do some amazing things as far as manipulating life, and people are even starting to synthetically copy DNA, which is really hard. But then to turn around and say, oh, yeah, and that just happened randomly. It's just, I mean, it's really, I don't even know how to describe it. You don't want to say, people, that's just a statement of faith where all the evidence is going against the faith that, somehow life just made itself. But
Yes.
anyway, yeah. So, but as far as, and I knew at least Strzok was he's just doing his research. So,
Well, and for those who are not really familiar with the radioisotope dating and all of that, I want to just state simply the significance of them observing changing decay rates, fluctuating decay rates, because one of the main principles that's this using radioisotope dating is founded on is unchanging decay rates.
right.
So if decay rates are changing, then that makes it the whole idea of using this as a clock totally out the window.
Yeah, yeah, at least exactly, because until we, and then what they could, the other one, and this kind of interesting, it's almost a lot of Christians may feel that they, okay, so this is a lot of maybes and ifs coming into this, but uh, they think, well, if God designed it so we could change radioactive decay rates, that's actually really dangerous. I mean, if you could really make big changes to radioactive decay rates, you could really do a lot of damage with that. And so they will actually say that it's probably just only an event that would happen, say, during creation week or the flood. So it's kind of but then people are seeing these fluctuations and we're trying to figure out what's causing them. So that's kind of the counter argument. So it's just kind of interesting. A lot of the Christians will say, we, for whatever reason, expect them to be stable, most of the time. And it's the non-Christians that are saying, yeah, but we're observing these fluctuations. So it's interesting, but you're right. It just is showing there's some things we don't know about the radiometric dating. Um, so yeah, it's a fun area. So I'll just go ahead and read these quotes, and they're still out on the Stanford website. If anybody wants to read them. And he's, unfortunately, his obituary is out there now too. But he says the research that Strzok learned about in Tucson concerned fluctuations in the rate of decay of radioactive elements. Fluctuations were highly controversial at the time because it had been thought that the decay rate of any radioactive element was constant. Strzok decided to study these experimental results using analytical techniques that he and Scargill, who was one of his other researchers, had developed to study neutrinos. Goes on and says, in examining the radioactive decay fluctuations, the team found evidence that those fluctuations matched patterns they had found in super Kamiokande neutrino data, each indicating a 1-month oscillation attributable to solar rotation. The likely conclusion is that neutrinos from the sun are directly affecting beta decays. That connection has been theorized by other researchers dating back 25 years, but the Strzok Fishback Scargill analysis adds the strongest evidence yet. If this relationship holds, a revolution in neutrino research could be underway. And so that's the other thing with any of these things. You really hope that there's an application, because then if there's an application, then you get the funding and you get a much more likely opportunity to really see what's going on, figuring out the basics of what's going on. And that's again true with any area. When they first when fission was first reported, back in the 30s, a lot of skepticism. There's no way you're going to split an atom, and then they just kept grinding away, and then they finally figured out fission works. And then unfortunately there was a big need for it, with World War II, or a big nervousness. And so we went from we already had a self-sustaining chain reaction. Chicago Pilot took less than a year to get it running, but that was and that wasn't even 10 years after there was still a lot of skepticism related to even the fission process, because no one could figure out how that could work or why that could work. So again, if someone finds an application and there's a lot of research put into something, they can advance really quickly. And I'm not sure, again, not everything goes different directions, but just an observation. A lot of things that things can advance really quick. So that was what was at least encouraging, is he was looking for applications for this, or potential applications for this. This is a quote from Astroparticle Physics, September 2012. Says additional experimental evidence is presented in support of the recent hypothesis that a possible solar influence could explain fluctuations observed in the measured decay rates of some isotopes. These data were obtained during routine weekly calibrations of an instrument used for radiological safety at the Ohio State University Research Reactor using chlorine-36. The detector system used was based on a Geiger-Muller gas detector, which is a robust detector system with very low susceptibility to environmental changes. Clear annual variation is evident in the data, with a maximum relative count rate observed in January, February, and a minimum relative count rate observed in July, August for 7 successive years, from July 2005 to June 2011. This annual variation is not likely to have risen from changes in the detector surrounding, as we show here. So again, just people kind of following up on the work. So that's the idea that okay, if we're seeing these fluctuations now, but and so that's interesting. But the I guess the other observation, though, is if they were much larger, and then just other places are reporting this data on changing radiometric decay rates available from Brookhaven National Laboratory, Long Island, and Federal Physical and Technical Institute of Germany. And they're now a lot of researchers are claiming both alpha and beta emitters show changes. So it's interesting. It's going to be interesting to see where this goes. So, but the point again is, this, if there was a significant change in decay rates during creation week and the flood, then that makes all the ways of estimating age really become consistent with each other. And so that's what these could lead to, or this could be just fluctuations now that don't have anything to do with how those decay rates might have changed, during creation week of the flood. So it's but again, just one avenue that people have been looking at. Now, another avenue is they just look at, okay, are there just things that aren't making sense? And so that's kind of like how you find carbon-14 in a diamond. That doesn't make sense. So there's something wrong with the assumptions there, because the diamonds are supposed to be way too old for any carbon-14 to still be in there. The diamond has a very strong crystal structure, so you won't have carbon-14 migrating in and out. And so so here's another one is, okay, if you're looking at dating a sample, usually you're lucky to just have one isotope chain that could be used to estimate an age. But if you have basically the same sample, and this is from the same rock formation, but say you had multiple ways of estimating the age, well, why don't they all agree? Because that's another inconsistency. And a lot of times you get what they call discordances. And so again, it's just an observation, but I would see in the upper left, that's the uranium lead date. I think it's like 1883 million years, that estimate. You have rubidium strontium down there, kind of in the middle, down low, it's like 1240 million years. And then you have a samarium, I think that's samarium neodymium up on top right there, and it's given like a 1600 something year. And so everybody look at that and they say, first you can say, okay, well, I don't know exactly how old it is, but those are all given dates over 1 billion years old. That's thousands of millions of years on the left axis. So at least we should know that it has to be more than 1 billion years old, because I got 3 independent dates. Dating methods, all of them say it's over 1 billion years, but that's the wrong interpretation, because what we should really be looking at is, well, why don't the error bars, or why aren't they the same? In other words, why don't the error bars overlap? And so I'll go back, I'll use my pen again. say we had a situation where the sent to that same lab, and it said the pen was 100 meters long. And so I said, well, how sure are you about that? And they said, well, it's 100 meters long plus or minus a meter. And so I'm still not sure I believe them. So I sent it to another lab, and they say, oh no, it's 200 meters long plus or minus 2 meters. Okay. And so I'm still like, well, that just doesn't seem right. So I sent it to another lab, and they say, oh, it's 300 meters long plus or minus 3 meters. Okay. So I guess the only thing I know for sure is this is at least 100 meters long, right? Because I've got 3 estimates now, and they're all 100 meters or more. So I can be confident that this is at least 100 meters long, but that's not what I should be, thinking about a little harder. It can be like, well, wait a second. If they're all using similar assumptions, similar methods, and they all gave me different answers, outside the normal error bars, then maybe there's something fundamentally wrong with the assumptions they're using, or something fundamentally wrong with the technique. And so that's the point that's made related to discordances in the estimated ages between rocks. We shouldn't be seeing these discordances, but they're very, very frequent. And so a lot of, and again, a lot of times you can't date, you don't have multiple methods of estimating age in the same rock, but when you do, you see these discordances. And so, anyway, that's okay. So, that's one. If we really got a lot of data, and there seems to be correlations between whether it's an alpha emitters tend to err on one side, beta emitters err on a different side. The atomic mass may have an effect. So people are they're just kind of noticing trends. But if we just really did a concerted effort to get as many of these samples as we could, and then start looking at the discrepancies in the age estimates, then we should maybe be able to start figuring out, at least we would know, well, is there a relation in these discrepancies to the atomic mass, or whether it's an alpha or beta emitter or an atomic number. And then, maybe we could start advancing that way. But that would be an application, but it's, they're just, no one's ever seemed to be able to get support for that. But it would be a really good, just get thousands of samples, get a very objective, accurate lab. A lot of times now the labs will actually ask, say how, date the sample, tell me how old it is, and they'll immediately come back with, well, how old do you think it is? I mean, that's horrible, but that's, so you'd have to get a very independent, objective, we don't care what the answer is. We'll just, we'll tell you what our data is, type of lab. So, which, I'm sure they're out there. Now, so the other one, this was the helium retention in zircons. And this was originally Don DeYoung, but several others did this research. And they, I think they got these zircons, might have been Fenton Hill outside of Los Alamos, New Mexico. And what they did, though, was these are zircon crystals. And they, a lot of times when that crystal's forming, you'll end up with a small fraction of uranium in the crystal. And then what it will do is, as that uranium then decays, this is essentially, if you have uranium-238 decaying to lead-206, you'll end up with 8 helium nuclei. Okay, so you have this decay of the uranium, and so you can measure now both the uranium to lead ratio, and that can give you an estimate if you make the assumptions, constant decay rate, no lead at the start of when the sample started decaying, nothing goes in and out of the system. You make those assumptions, you can say, okay, based on the fraction of uranium that would have turned into lead, we think it's this old. A lot of times it'll be like 1.5 billion years old, really long age. But then what you can also do is you can say, okay, here's what we think the temperature was in the area, throughout history in this area where the zircons were formed. And how much helium should stay in there. In other words, how much helium should we still find? What we find is there's still a tremendous amount of helium inside these zircons, and that helium should have diffused out. It'd be like if you went into a room and there was a balloon up on the ceiling, and and so you're thinking, oh, someone must have had a party here this morning or yesterday or something. So it was a helium balloon floated up to the ceiling. But then someone came in and said, no, that was 50 years ago when we had the grand opening for the building, that helium balloon, someone let it go and it's been up there ever since. Well, you think, well, that's kind of inconsistent, because you have data, how fast the helium diffuses out of the balloon. And so that's kind of what we're seeing here. We know how fast the helium diffuses out of the zircons. We know how much helium should have been there based on the amount of uranium that turned into lead. Because again, every time a uranium-238 goes to lead-206, you get 8 helium atoms. But there's just a very large amount of helium in there than much larger than there should be. It's actually like a factor of 100,000. Okay, so much more helium in that zircon than there should be. And so they actually published they sent it off to a lab, independent lab, to see, okay, how much helium's in here. And they published, though, their prediction before they got the samples back. And their prediction, again, was based on a 6,000-year-old Earth, and it ended up matching the data exactly. And so, again, a lot more information in the book. Is called Thousands, Not Billions, just the details behind the samples and the experiment that they performed. But again, it's so in this case, the most consistent interpretation of this data is that, yes, you had a lot of radioactive decay, you had a lot of uranium-238 turning into lead-206, but it had to happen recently, because if it had not happened recently, the helium would have diffused out of the zircons. So again, it's just an observation, but it's very, again, consistent with the biblical account. In other words, the idea that the Earth really is again on the order of 6,000 years old. Then you do get a lot of discussion points related to radiometric dating. One is, if radioactive decay rates were greatly accelerated, wouldn't the resulting energy melt the Earth? And if they were greatly accelerated and you had the same amount of energy released per decay as we see now, then that could be a true statement. Things would definitely be heating up. We don't see any evidence that happened. But the point is, we really have no idea how that decay rate would have changed. And so we also don't know what effect that would have on the energy released per decay. And if the idea is pursued further, again, look at just the ways radioactive decay rates for a given isotope could be accelerated or reduce the energy released per decade. And talked about this briefly, but a lot of times people will say, well, the Bible talks about stretching a space 17 times, or alludes to it 17 times. And the example verses are Job 9:8, Isaiah 40:22, Isaiah 42:5. So what effect could that have on decay rates? And no one really knows. No one really predicts it. And so again, everybody's like, yeah, but that's just the Bible talking about stretching. So it is really interesting. Again, especially in the Big Bang, the idea that space itself is stretching. It's basically fundamental to their model, but they just very careful in their terminology so they don't get accused of talking about a miracle. Although really, by any definition, the whole idea of the inflation happening just very, very, very rapidly and shortly after the Big Bang. That's no idea what started it, no idea what ended it. It's just needed to make their try to make their equations work. I mean, that's again, you could call that a miracle, or I mean, it'd be basically has the same properties of a miracle, I guess you would say. And I should mention, though, the Bible, the biblical account wouldn't use stretching of space in the same way, but it would still use this, could use this phenomenon of stretching of space. And again, that's alluded to many times. Now, there's also just the inaccurate dates, and these are humorous, but they're still kind of damaging because they just start, it just gets back into people's minds that, well, I saw this, this volcano that was erupted 3 million years ago. And again, that's not a biblically consistent date. And so one example, there's samples from the 1954 eruption of Mount Narahu. I probably mispronounced that, but in New Zealand, yields a potassium argon age as high as 3.5 million years. And so, it's kind of humorous because everybody saw it erupt in 1954. And so it's really not used in attempts to discredit the Bible because, again, it's a known, just you knew when that eruption occurred. But you're in the same museum, literally in this museum down in New Zealand, and you're walking through, and like 3 exhibits down, you have this display where it says it's something like, well, this volcano erupted 551,000 years ago. Okay, so if you weren't looking for it, that first one is just kind of a humorous one, but then all of a sudden, oh, okay, so wow, 500, they've down to the 1,000 years, 551,000 years ago when that volcano erupted. Well, in the back of your mind, you're like, okay, well, that's not really consistent with the Bible. But the whole point is they just said that dating method, they know can be off by millions of years. The same dating method was used again, to get this 1954 volcano to be very old, but they use that same one to also estimate the 551,000 years. And so it's subtle, but it actually can do some damage. And of course, there's no reason to believe either of those dates, again, based on the demonstrated actually the method used. But still, again, just that it's just really subtle, but it's almost permeates a lot of what people are exposed to, what people see. So summary. There is significant evidence against typical or uniformitarian assumptions. We have the reported fluctuations in radioactive decay rates. And again, that's not as accepted as the soft tissue and dinosaur bones. Just the soft tissue and dinosaur bones, though, is also very, very consistent with dinosaurs, living very recently, which is also very, very consistent with the younger Earth. And so, but anyway, there are reported fluctuations by very reputable researchers in radioactive decay rates. Carbon-14 in coal and diamonds should not be there if coal and diamonds were anywhere near as old as they're claimed to be. Discordances in age estimates based on radioactive decay. Again, just the different, using different decay chains to date the same rock, giving different ages, outside the standard deviations. Significant helium in zircons, and then significant errors dating rocks of known ages. And so again, as we were mentioning, the accelerated radioactive decay during creation week and the flood could explain discrepancies with other secular dating methods and with the Bible. So again, just summing up, true science is a Christian's friend. 1 Corinthians 10:13. No temptation has overtaken you except something common to mankind, and God is faithful. So he will not allow you to be tempted beyond what you are able, but with the temptation will provide the way of escape also, so that you will be able to endure it. What I mean by the temptation there is, again, tremendous evidence that the Bible is God's inerrant word. Talked about several of them tonight, not even outside of this particular area, but there's always the temptation just to just try to fit in and don't avoid disagreements and things. But we just need to avoid that temptation. And even if we have to say, we're not, here's the evidence we have, and then we're and then just discuss it with people. But again, if the goal is loving our neighbors as ourselves, really get them back into a lot of the real fundamental reasons that we know we should put our faith in the Bible. 1 Timothy 6:20-21. O Timothy, guard what has been entrusted to you, avoiding worldly and empty chatter and opposing arguments of what is falsely called knowledge, which some have professed and thus gone astray from the faith. Grace be with you. And then finally, every now and then someone's going to they might ideally say something like, well, okay, you don't believe this, or you're not they might just say something like, well, what do you believe? And the really important thing to say there is it does not matter what I believe, and this especially when we talk about the plan of salvation. It doesn't matter what I believe. Let's see what the Bible says. Romans 1:16 says, for I'm not ashamed of the gospel of Christ, for it is the power of God to salvation for everyone who believes, for the Jew first and also for the Greek. And then we have all kinds of examples in the book of Acts of people being saved. Acts 2:36-47. People are told to repent and be baptized. They will receive the gift of the Holy Spirit. And it answers so many questions too. If someone says, you don't know what I've done, there's no way God would want me to be saved. Well, first of all, 1 Timothy 2:3-4 tells us that God wants all men everywhere to be saved. So he does want all men to be saved. And second of all, these are the people that had crucified Christ. And so if God wanted them to be saved and allowed them to be saved, then certainly, that's backing up what he said, that he wants all men everywhere to be saved. And, talks about, just how God adds us to the church, once we've basically just obeyed the gospel. And so a lot of good examples. So I just say that because, again, these are fun discussions, but, push comes to shove. We really want to be thinking about people's eternity, not just having fun technical discussions with them. And so, just from the biblical examples, when someone says, well, you need to, hear God's word, you need to believe Jesus is the Son of God, you need to repent, start to do what God wants us to do, not just what we want to do. Confess Jesus as the Son of God, be baptized, be immersed in the water in the name of the Father, Son, Holy Spirit for the remission of our sins, and then remain faithful. Well, that's where they get it from. They get it from the Bible. And so that's the direction we should be sending people. So anyway, I think maybe we'll have time for a little bit of discussion now, but those are just some slides going through just to try to get things started.
Yeah, and I love you bringing it back around to the purpose, because that is the purpose. This is why I'm doing this channel. It's ultimately because I want people to know the truth about God. I want them to know they didn't come about by natural processes, that the scientific evidence is actually against that,
Yeah, yeah,
and that the scientific evidence, if you follow it where it leads to a creator, it leads to a designer of life. And that designer of life has revealed to us in the Bible that he loves us and he wants us to be saved.
yeah,
And, maybe you've gotten disappointed with the corruption in the world. Well, God is disappointed with the corruption in the world
yeah,
too. Okay. And he actually says this is not a place that's fit for his children to live forever. So he
mhm.
has promised to make us a new place, and he's going to come back and bring us to be with him where he is. That's what we want you to know. And so, we're doing this because I see people losing their faith or not being able to come to faith because they've been convinced that everything has happened by natural processes,
Yeah.
no creator needed, and it keeps you from seeing the best evidence that God has given us for his existence. He wanted you to be able to look out in the
Uh-huh.
world
Uh-huh.
and see that he has made things, that all of this is beautifully designed by him. So he wants you to have that evidence for his existence. But this idea of evolution and things coming about by natural processes can block that.
Oh yeah,
So,
and it's right in Romans 1, where it talks about professing to be wise, people will become fools, by saying, "Oh, this all just made itself," or it says we know about God's eternal power and divine nature, and then the last half of that chapter, does give us, a lot of the consequences if people do deny God as the creator, and so, but again, just I think I know you've had some great discussions on your show here, and but just really, you know, just really how to phrase it. There's some very straightforward ways to get someone thinking. And it definitely can show that there's true science is catching up with the Bible. As I mentioned, we talked about like the headlines related to the amino acids, and there was if you go back, you look at the story of the year in 1907. Cover story in the Wall Street Journal. The best. 1907. The most exciting news was the proof afforded by astronomical observation that there's human life on Mars, and wow. I mean, that is big. And so that was 1907, and then even in 1915, you still had the American Museum of Natural History in New York. They had a journal, quote unquote peer reviewed journal. That's another one of the things everybody's supposed to be intimidated by, and they were saying. Oh yeah, here's all these markings and this, and it can only be done by, basically a very eloquent word. He was saying, oh, it has, this is further proof there's people on Mars. So that's 8 years after the Wall Street Journal, and is in a so-called technical journal. And of course, now we know that, all the evidence is there's not even a bacteria on Mars, so it's, so you go from, oh, we got proof that there's humans and so again, true science catches up with the Bible because of course, just God creating life on Earth, that's very biblically consistent. Now, people could, well, anyway, we could talk about that for another hour or two. So we'll just.
well, I wanted to ask you a few questions about radioisotope dating because, so we talked about the assumption that may be false about the decay rates. But what assumptions do you think that people are making that are leading to get these billions of years? Like you talked about the pencil, okay, and well, some people may look at those age discrepancies, and even though they don't overlap, they would say, well, we may not know the age of the rock, but we know it's at least 1 billion years old.
Right. And
So what is your response to that?
it's really just know that if there's those kinds of discordances, there's something wrong. I mean, because this pin, it can't simultaneously be 100 meters long, 200 meters long, and 300 meters long. I can't remember if I use feet or meters, but
Right.
you
No.
can't.
Yeah.
It can't be 100, 200, and 300.
Right.
Two of those have to be wrong, and if I'm using the same fundamental assumptions when I'm measuring that pin, it's reasonable and possibly probable that all three of those are wrong. And so that's really the way to look at it because
okay, so you're not sure about what is wrong, but you're just
yeah,
saying something's wrong.
yeah. And so the one that would make everything correlate, okay, and so that's again, it would just be if during creation week and during the flood there were accelerated decay rates. And so creation week, to me, that ties in very well with this. And I don't want to say what caused them, but it is just interesting that what we would call creation week is where you would have definite evidence for the stretching of space. And the secular astronomers believe that. Now they'll call it, the inflation at the start of the Big Bang, da 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 da. But they also agree that space has expanded. So that's an interesting. And then during the flood was also a miraculous event. Was there something that would have accelerated decay rates during the flood? Could have been the same mechanism, could have been a different mechanism. But I don't know what exactly that mechanism is. Now there's a chance it could tie back to these whatever mechanism might be causing these fluctuating radioactive decay rates. But there's also a really good chance it wouldn't. The point, again, that some people make is if we figure out a way to make radioactive elements instantly decay, some people will say, "Oh, that's great! You just solved the nuclear waste problem." Yeah, but it's got to have that's going to have a lot of implications. If so, then the question is, would God have really designed things to be that way or not? And so, but so that would just be like, could you go out to a nuclear waste repository and just magically make everything decay all at once? That would be really, I'll just say bad. So it's so anyway, so a lot of just the idea is, okay, how are we gonna, what could we do to find out? There's a lot of research on if they're fluctuating or not, but then also just what could be some of the mechanisms that would possibly accelerate them. And we can't stretch space in a lab, and that's the problem. So we can't really duplicate that effect. And there's a lot of other effects that we couldn't duplicate either. So that's one, at least at the moment, you can't say, okay, this is definitely the cause. Now, someone could come up with something. I'm not saying they wouldn't, but at least at the moment, you can't say, okay, this is exactly what happened during creation week and the flood. So.
Yeah. Well, and so you put up 3 different assumptions. I think it was 3 that we make with radioisotope dating. Have you looked into the other assumptions, like daughter element changes and stuff like that, like the daughter element?
Yeah, a lot of people will feel there's a lot there also. Like are there elements or isotopes being transported in or out of the system over that period of time? I think might be with radio halos, and that's more for evidence of the flood, that you have to just the way the radio halos can be distributed. You had to have basically warm water is dissolve certain elements more than other elements, and that explains a lot of things. So it's and that would have been that those could be showing accelerated decay during the flood. So that's one. And that would be probably fall into that category. So there's a lot. I know there's a lot of people have done some really good work related to the other 2 assumptions as well. And so I kind of focused on the just one of them, and you always, you don't want to say, you have everybody's got kind of their favorite, I'll say idea, especially when you talk about, like, okay, why does the universe appear the way it does from an Earth that's 6,000 years old? And it's interesting. You have very, people have really thought it through, but everybody will kind of have their favorite ideas to, and there's, several different ways that happens or could happen. But people do kind of gravitate to whichever one. It's also depends on their background. Whichever one they think is the how to phrase it, the best way that God, during creation week would make, did things in a way that the universe looks the way it does from an Earth that's 6,000 years old. So it's probably kind of analogous on the radioactive decay or radiometric dating also.
Yeah, and actually I had my friend Van came on last week, and he was, well, by the time we put this video out, it'll be 2 weeks ago, but he talked about radiometric dating and what he found with the problems with it. So I'd love to hear your thoughts on what he said.
Oh yeah,
but
I'll watch it for sure. Yeah, no, that's great.
Cool.
Yeah.
And the other thing that you brought up was the radio halos, which I kind of had forgotten about. But the radio halos mentioned in the Rate Project book, they found that the radio halos, they cannot be produced unless there is like an accelerated decay or something. Like they can't, if they're just decaying at the normal rate, you wouldn't see those radio halos. And yet we see them.
Really get a radio halo discussion in there. Yeah. So there's a lot of subtle things, and yeah, it's really just exactly. But yeah, I'll look forward to hearing the additional discussion. That's great.
Yeah. Well, thank you so much for your time. And I really appreciate you coming on and sharing this. And if you want to come back, please do. Thank you, everybody, for watching. And please do put comments if you have questions or get in touch with Dr. Houts. He put his email. Should we put your email back up on the screen?
Sure. Yeah.
Here it is if you want to get in touch with him.
And there's also a lot of really good information just out on the apologeticspress.org site. Yeah, a lot of just articles and presentations and stuff also. So either one of those is great.
Awesome. Is that a site you contribute to?
Sometimes, yeah.
Great.
Yeah,
Well,
really good work out on that site. Yep.
So radioisotope dating, not good evidence for an old Earth. Actually, as you saw Dr. Houts put forward, is that the bulk of the evidence, scientific evidence, supports a young Earth. So you have to kind of dismiss all of that evidence and then accept radioisotope dating, which has a lot of built-in assumptions in order to get the Earth to be 4.5 billion years old. So thank you so much and take care, everyone. God bless you.
Yeah, thanks everybody. Appreciate it. God bless you.